Assalamualaikum and very good afternoon. So we'll continue to our first lab session, which is Ohm's Law guided lab. So previously I wrote it as free lab 1, but actually to make it more understanding, we call it as guided lab for this semester. So the objective here, upon completion of this experiment, students should be able to demonstrate the validity of mathematical relationship between the electrical voltage U, the electrical current I, and the resistance in a closed circuit. The second one, observe and analyze the Ohm's law curve for respective resistance given in this experiment. So the general information here, Ohm's law defines the mathematical relationship between the electrical voltage U, the electrical current I, and the resistance U equal to IR. Okay, where I equal to electrical current ampere, U electrical voltage unit volt, and R electrical resistance unit ohm. In a closed circuit, the current charged proportionally to voltage at a constant resistance. If the resistance is changed at constant voltage, current and resistance behave inversely proportional to each other. So now we continue to the experiment procedure. 1.3, the curve I equal to function of U at constant resistance R and I equal to function F of R at constant voltage U should be plotted statically. Okay, experiment procedure. In order to plot the curve I equal to function of U, first set up the experiment in accordance to figure 1.1 and measure the current respectively at the resistance and voltage specified in table 1.1. So this is table 1.1. Okay. Number 2, enter the value of the current in table 1.1. So this is the measured current for resistive voltage and resistance measurement table. Okay, you have to follow this. So basically we will measure based on voltage from 0 until 12 at resistance 100 ohm, 150 ohm and 330 ohm. So basically number 2, enter the value of current in table 1.1, thus plot the graph in 1.1. Okay, number 3, in order to plot the curve I function of R, assemble the circuit in accordance to figure 1.2 and measure the current respectively at the constant voltage 4 volt, 8 volt and 12 volt, dependent of the resistance specified in table 1.2. Okay, so basically we have two experiments here, figure 1.1 and figure 1.2. Basically it's the same circuit, but the parameter is quite different. For table 1.2, measured current for respective voltage and resistance. Alright, we need to measure the current, and then we have to plot graph 1.2 current versus voltage curve for 12 volt, 8 volt and 4 volt. Okay. Alright, and then number 4, enter the value of the current in table 1.2 and plot the graph in graph 1.2. Number 5, compare measured value and calculated value by using Ohm's law equation. This is what, like I mentioned before, every time before we go to the lab, it is very important for you guys to calculate the theoretical value. Otherwise, we cannot compare our data between the measured data in experiment and theoretical value. Okay, we want to see the difference, the gap, so that later we can do the discussion. Okay, why this happen, why there is a gap between theoretical and measured data, and so on. Right, so it's very important before you go to the lab to calculate first all of the theoretical value, if the parameter given permit you to do the theoretical calculation first. So this is for table 1.1. So this is for your information, this is just for your reference. Later in your report, maybe we will do you will do the more table in the report letter. For example, table 1.1a is for theoretical value, calculated based on the parameter given, and then table 1.1b is for the measured data. Okay, and then maybe 1.1c, it depends if you have more data. Maybe 1.1c is for calculated current value based on the actual resistance value. Okay, because we don't know in the experimenter either the resistor given is have the same amount of resistance with whatever written on the resistance. For example, 100 ohm, is it truly 100 ohm that we are measuring later? So we need to know what is the actual value of the resistance. Okay, and then for data plotting, you will do it in Excel and then transfer it to Word. Okay, that one you need to learn how to create a graph in Excel and then transfer it to Word. So guys, today we will do our first guided lab, which is Ohm's law. Okay, so previously I already read to you the experiment procedure. So now we going to create the circuit based on the schematic diagram. So first we will do the for figure 1.1, measured current for respective voltages and resistance. So basically we are using 100 ohm, 150 ohm and 330 ohm. Okay, so first we go to 100 ohm. Okay, so basically this is the 100 ohm. Okay, so before we connect to the circuit, we want to know what is the actual resistance for this resistor. Okay, so I'll be using digital multimeter. First we need to set to ohmmeter. Okay, right. So I will touch both leg. So here is 98.7 ohm. Okay, 98.6 ohm. 98.6 ohm. Okay, so you need to, when we do an experiment, we need to jot down the actual value for any component. Okay, for like 400 ohm, so now we are measuring the 90 98.6 ohm. Okay, now I connect the circuit. Okay, so make sure we do the right connection on the breadboard. Okay, and then I need the jumper here. Okay, this one. Okay, like we have learned previously, this line is already internally connected. Okay, so from the power supply, this one from the power supply. Okay, so from here to here we need to do a direct connection for the ammeter. So this one we could change to emitter mode. Okay, so the positive side we will connect to here. Okay, and then negative side will connect to here. Ini tak ada connection ni. It's okay. I will touch it here later. Okay. So this one is from the negative terminal from the power supply. Okay, now I will measure for V equal to 0. So the reading here is near to 0.02 milliampere. Okay. Now I will increase the voltage to 2 volt. You can see here measured current will be 19.22 milliampere. Okay, now I will increase the voltage to 4 volt. If you can see here, the reading will be 37 point. The reading will be 38.4. Okay. Then I will increase to 6 volt. The reading for 6 volt 100 ohm is equal to and 57.4 milliampere. Okay, off. Then I will increase the supply voltage to 8 volt. So the reading here is 76.7. For 10 volt. The reading is 97.3. Then the last one increase to 12 volt. For 12 volt, the reading is 118.9 2. Okay. Now we will change the resistor to 150 ohm. So this is 150 ohm resistor. Connect it here and here. Alright. Okay. So we will continue again with from 2 volt. Okay. So basically that is the power supply. Okay. I change the voltage here. Okay. Okay. So this is 150 ohm. We will start from 2. Okay. So for 2 ohm is 12.83. Increase to 4. So the reading is 25.38. 25.38. Then we increase to 6 ohm. The reading will be, so this one is for 6 volt, sorry, not 6 ohm. 6 volt, the reading is 38. 38.2. Then we go to 8 volt. The reading is 52.3. 52.3. Now we go to 10 volt. The reading will be 65.5. 65.9. 65.9. Okay. Then we go to the 12 volt. So for 12 volt, the reading is the reading keep increasing. (79.8 milliampere). Okay. Then we go to the next one is 330. Okay, so this one is 330. I already connect it to the circuit. So the third one for table 1.1 for 330 ohm. Okay, But before that, we need to measure what is the actual resistance for this one. Okay. So I change the mode to ohmmeter. So reading here is 325 ohm. Okay, 325 ohm. Okay, even the label is 330, but the actual is 330 ohm. 325 ohm. 325 ohm. Okay, 150 just now. The actual resistance is, okay, make sure you know what is the actual resistance so that you can do the discussion. Okay, and know what is the reason why is the actual data different with the theoretical data. So this one is 147.1. Okay, now we want to measure the 330 ohm, and the actual one is 325 ohm resistor for table 1.1. Okay, now we'll start with 2 volt. For 2 volt is 5.90. Okay, so 0 is 0. Now we go to 4. So for 4 is 11.92 milliampere. 11.92 milliampere. Now we go to 6 volt. So for 6 volt is 17 point, it's increasing, 17.93. Now we increase to 8. For 8 volt is 23.8. 23.8. For 10 volt is 29.8. 29.96. 29.96. For 12 volt is 36.06. Okay, so we finish take the measurement for table 1.1. Okay, now we want to do the measurement for table 1.2. Okay, current for respective voltage and resistance. Okay, we start with 100. So we use 100 first. So we're using 3 variants of voltage, 4 volt, 8 volt, and 12 volt. Okay, so we start with 4 volt first. Same connection. Okay, 4 volt. So 4 volt, the reading is 37.78. Okay, then we go for 8 volt. So reading is 76.5. Now we go to 12 volt. Reading is 118.3. Okay, now we go to 150 because we need to off the circuit first. So 150. Okay, we use the actual value for 100 is 98.6 ohm, and then 150 is 147.1 ohm. Okay, so this is 150. All right. Now we go to 4 volt first. Okay, so this is 4 volt. The reading is 26.27. Now we go to the 8 volt. So for 8 volt is 52.1. Okay. Then we go to 12 volt. The volt is 79.7. Okay, now we go to the next one is 220. Since 220 is the new resistor, so we need to measure first. Change to ohm. Okay, then here, here. Okay, so the reading is 218.2. okay, 218.2. right, so we connect it here and here. Okay, so we sure the connection is good. Okay, set to 4. Okay, switch on. Oh, sorry, ammeter. Okay, 4 ampere, so the reading is 17.51. 17.51 for 4 volts, 17. 4 volt, and then go to 8 volt. Okay, on, so we get 35.27, 35.3, 35.3, 35.32. Then we go to 12 volt. For 12 volt is 53.3.2. Okay, now turn off, change the resistor. We're using, next one is 330. This one is already measured. The actual one is 325 ohm. Okay, so we start with 4 volt. So the reading is 11.86. Turn off. And then for 8 volt, is the 24.01. Then 12 volt, it's 36 point. .71. Okay, next we go to the 450. Make sure everything is off. Pull out the resistor, and then next one is 470. Okay, but we need to know the actual resistance first. Okay, so resistance here is equal to $461. Okay, this one is 461. 461. Okay. So change this to emitter, then turn on, set to 0.4. So the reading is 8.45 ohm. Now we go to 8 volt. So 8 volt is 17.00. Go to 12. Is 25.5, 25.59, 25.60. Okay, finish for 461. Turn off, pull out, resistor. Now we go, the next one is this one is 680. Okay, this is 680, but we don't know the actual value inside. So now we continue to 680. So the actual is 668, right? 668. So we now continue to the second last for 668. Okay, 668 ohm. Okay, make sure the connection is good. So this one is ammeter, right? So connect here the power supply. Okay, start with 4. Okay, so the reading is 5.92 for 4, 5.92. Okay, now we go to 8. The reading is 11.73. Now we go to the 12. Okay, on 17.67. Now okay, turn off. Then we go to the last one, is 1K. So this is 1K. Okay, make sure you measure first, because we don't know what is the actual value in this resistor. Okay, is it 1K or below? Okay, so you can see here the value is 0.978. So 978 ohm. 978 ohm. Okay, 978 ohm. Okay, so in the theoretical later, you need to calculate the theoretical based on actual value of the resistor. Okay, so this is 1 kilo ohm, 978 ohm. So change the ammeter, then do the connection, make sure everything is good. Okay, don't do the connection, the full connection, before you set the power supply. Okay, so set first. So I set this to 4. So 3.93 milliamp for 4 volt. 3.93. Now we go to 8 volt. So 8 volt is 8.04 milliamp. 4 milliamp. And then go to 12 volt. .06 milliamp. Okay. So basically in the instruction, before we go to the lab, we will do the theoretical part first, theoretical calculation first. If we are given the parameter, okay. For example, this one you already know the parameter 100 ohm, 115, 33. It's good for you to do the calculation first, and then when you come to the lab, you do the actual measurement and you know the actual measurement data, and you can also do again another true value calculation to be compared with the measured value. Okay, that's all for today. Thank you.